All right, this is lesson 3.2.3, and uh, feel free to have the Pear Deck open as you're watching the video so you can fill in the slides as you go through the video. And the first slide is explaining um, we're going to be working with removing positive and negative tiles to represent a number. And you will extend your thinking to find ways of making your calculations more efficient when the same number of tiles are removed multiple times. So when we take away groups of numbers, consider these questions as you work today. Is there a more efficient way to do this? How do these ideas compare with what we learned about adding and multiplying integers in Chapter 2? Okay, so we're looking at the first example on the first slide. For each of these expressions, predict what do you know about the result without actually calculating it. Can you tell if the result will be positive or negative? So draw a plus or a minus next to each expression and be ready to explain your ideas. So in the first one here, we have -1, and we are taking away 6 negatives. So what would that be in terms of positive or negative value? So yesterday we talked about when we subtract a negative, it's kind of the same thing as adding a positive. So -1 minus -6.5 would be a positive value. So if we look at B, 2.2 minus -2.2. So go ahead and do the same thing, because when you're subtracting a negative, you can see that as adding a positive, and it would give you a value of 4.4. Okay, so for C, 12.5 minus 22.5. Would that be negative or would that be positive? So sometimes when we subtract, it gets a little bit complicated. So what we did yesterday in class is we just rewrote the subtraction as addition. So this would be 12.5 plus -22.5. So when we're thinking about tiles, we go 12.5 this way, that's positive, and then 22.5 negative that way. So that would definitely give us a negative value. Okay, so go ahead and answer D and E following the same pattern and fill that out in your Pear Deck. Pause the video if you need some time to do that. Okay, so on the next slide, we are describing the diagram for each of these expressions and calculate the number that each of them represents. So we're describing these in words. So I will help with the drawing of the diagram, and you can just describe that on your Pear Deck slide. So we're starting with a -1, and we are subtracting -6.5. So what happens when we subtract 6.5 negatives from one negative? The drawing with pluses and minus tiles, we would have to add a bunch of zero pairs. But since we learned yesterday this little shortcut, I can just change this minus negative to a plus. So -1 minus -6.5 would look like this. So feel free to describe that on your Pear Deck. Pause the video if you need time to do that. And looking at the second one, you have 2.2 minus -2.2. So describe what that would look like in the same way. Okay, and remember what we learned yesterday. Pause the video if you need to finish that slide. Okay, next one, 12.5 minus 22.5. I already drew that one for you, so just describe it out. And then for D, negative 100 minus negative 98. Okay, we already know that that would be a negative value. And here's what the drawing would look like. Describe it in words, please. Okay, so I'm moving on to the next slide. So now describe a diagram for each of the expressions. For this one, you have negative 10, which means we would go 10 this way. And then we are subtracting negative 2, which we know would be this. So we go 2 that way. And then we go 2 that way again. And then we go 2 that way again. Right? We're subtracting negatives, which means we're pretty much adding positives. Okay, so now that we have the diagram for that, it's 10 minus negative 2 minus negative 2 minus negative 2, which would give us a value of okay, so this is the value that it gives us. So in the next slide, we're working on the same problem, and it says, how can we find a shorter way to write this expression? So if we're taking away 3 groups of negative 2, we can just write that as negative 10, take away 3 groups of negative 2. Because we're taking away 1 group of negative 2, taking away 2 groups of negative 2, and taking away 3 groups of negative 2. So we can use multiplication in this case, just like we did with addition, except in this case we're taking away. So we have 10, take away 3 groups of negative 2. So this slide is asking us to consider that last expression that we just worked with, and imagine that the expression does not include the negative 10. So how could we write the new expression? So we know that when we take away 3 groups of negative 2, it's kind of the same thing as adding a positive 6, right? So if we take away this negative 10 from the expression, we're basically taking away 3 groups of negative 2 from 0. So we're kind of assuming that this 10 does not exist. We're just taking away 3 groups of negative 2 from 0. Now here's the logic behind this. If I were to have a number like 4, and then I'm going to add 2 plus 2 plus 2, it's the same thing as 4 plus 3 groups of 2. So if I take that 4 away from this, I basically have 6, which is 3 groups of 2. So I'm adding 3 groups of 2 pretty much to nothing, to 0. So that's 3 groups of 2, 3 groups of 2. So this is how we can show multiplication of positive numbers. But if I'm subtracting 3 groups of negative 2, like in this problem right here, I'm taking it away from 0, which will leave me with positive values. Okay, because if we look at the diagram, let me get rid of this first. When we look at the diagram right here, we can see that when we take away 3 groups of negative 2, it's the same thing as giving us a positive 6. So we are adding 6 to that negative 10. And this is how we would get that diagram to show how a negative times a negative is a positive. So this is what it would express. Okay, so To answer the question, if you were to describe what this expression represents using plus or minus tiles, what would you say? You could just kind of say that, well, if I multiply a negative times a negative, I'm going to get a positive. Now, using that logic, we evaluate the product -4 times -3. How can we make sense of this? How can we show that -4 times -3 equals a certain value? And so let's think of it the way we just did. So we have -4 times -3, which means we are basically taking away 4 groups of -3. Now, if we look at this as a diagram, we're taking away 4 groups of -3 from 0. There's nothing here. We're taking away 4 groups of -3 from 0. And when we learned the subtraction diagram, we learned if we're taking away 4 groups of -3 from 0, we first have to have 4 groups of -3 to take away. So we have 12 zero pairs. Okay, so we still have 0, and now we can take away 4 groups of -3. There's 1, 2, 3, 4. And when I take away 4 groups of -3, it equals 12, because I have 12 positive ones left. So this would be a diagram that shows how a negative times a negative is a positive. -4 times -3 is a -12, because we think of it as taking away 4 groups of -3 from 0. So when we look at this slide, explain with a diagram what it means to multiply a negative number by another negative number and to multiply a negative number by a positive number, and use the example 2 times -3 and -2 times -3. Okay, so one way that you would be able to show it would be we're adding 2 groups of -3 to 0. And then for the second slide, we're subtracting 2 groups of -3. So once we take away those 2 groups of -3, what do we get? Okay, so if you're describing that, go ahead and pause the video so you can fill out the Pear Deck slide. Okay, so the next question is asking, what does -18 divided by 9 equal, and how do you know? So how does your answer make sense? Now, if you remember anything about division, you have a number divided by another number. This first number is basically the product of 9 and something else. So 9 would be a factor, and -18 would be the product of 9 times something else. So when you think about it, what number can you multiply 9 by that will get you -18? And that would be 9 groups of -2. So this division problem, -18 divided by 9, your answer is -2. So you're using this logic to answer these questions here. Okay, so I'll do the first one, and then you guys can fill in the slides. To get the second, raise your hand if you have any questions, and I can help. So the first one, complete the division problems below. So you have 45 divided by -3. Again, this is the product of 3 and something else. So it's a factor. So what number times 3, -3, is -45? And can I have -3 groups of something? or 3, or a certain number of groups of -3 to get 45? No, I would have to take away 3 groups of -15 to get positive 45. So here we have -3 times -15 equals 45. Because you have a negative number times a negative number giving you a positive number. Because what we just practiced was proof or evidence why a negative times a negative is a positive. Okay, so go ahead and finish B and C, and if you need help finishing those, please ask for help.